Hello everyone. In this recording, I'll be presenting the overview of responsive digital operations room demo. In this demo, we are leveraging the data that is coming from smart water supply network. This is a typical water supply network. You could see here you have main water pipes, communication pipes, supply pipes, and inside stop taps for end customer supply. So across the supply network, there are sensors placed at various points of the supply network. The sensors actually take the reading of temperature, pressure, motor amps. So what we are trying to do here is we like to monitor the network, the supply network through the sensor readings. Plus, whenever such incidents happen, people do respond, customers do respond, right? So they respond through apps, they respond through social media. So we like to layer in that factor as well. So using all these data sources, we like to monitor the network, see what is happening in the network, understand, and then if there is any issues that are appearing in the network, we like to resolve them. That's the case scenario for this particular demo. So in this demo, we have four main views. Network KPI view, where we are actually looking at the historical analysis of how issues are happening, what are the how much time we are taking to resolve them, which are the regions where these issues are appearing, what are the types of issues that are coming, and then not only regions, right? We can drill it down to the exact sensor location to see which is the area where we have most problems from. And then the second view is about real-time asset monitoring. In this view, we look at the network. We look at the network as a whole. We see what is the status of the complete network. We'll be able to see which type of anomalies are appearing. Is it a pressure anomaly, motor anomaly, temperature anomaly, etc. And then we'll be able to see what are the latest sensor readings from each of the locations in the network, and if there is any issue happening, we can see the status of the issue in this particular uh, monitoring view. And the next view is about, as we discussed, this is about issue, I mean how customers are pursuing the issues, right? And then how they're actually complaining the same in social media, how our customer care is responding to this, how we are able to resolve some of the issues. So that's where the sentiment analysis is covering. And then the last view is about real time case management. So whenever these issues are getting raised, we want to track how they are getting resolved. We want to see who is the person responsible for actually resolving these things, and then we need to give we want to give a view for analysts to see what exactly happened, what's the history just before this breakdown happened. So that's what we are trying to provide in this particular. So this is the solution flow. It's a high level solution flow. So there are mainly two data streams that we are using. One is IoT or sensor data stream. The other one is the social media stream, as we discussed earlier. So when I'm considering the IoT or sensor data stream, what we do is we stream in this data, and then in the incoming data we are trying to identify anomaly. So we can use advanced data science, or we can use simple rule based decision making to identify these anomalies. Once we identified an anomaly pattern, what we can do is we can assign a resource based on the type of damage we have identified, based on the anomaly we have identified, and based on the the availability, whether the resource is busy working on another job or he is currently available uh, to be assigned a ticket right now, okay, based on the load overall load he has. Also, other factor we consider in resource allocation is the vicinity. Okay, we want to optimize the resource allocation, so we want to see who is the nearest resource that can basically take care of this particular issue, and then based on the distance from the site where issue has been raised, we allocate the resource. So once anomaly got categorized and resource got allocated, we would automatically raise a case which will basically trigger an email notification to the resource, and then resource will reach the site of the site where issue has been raised, and then once he basically fixes the issue or resolves the issue, he can just send back the close the case, which will be captured again, which will uh, flow back to the main event flow, and then based on that we again change the status of the resource to available, and then we capture his location, etc. So that's how we use this IoT stream data. The second stream of data we are leveraging here is social media data. So we are capturing all the tweets that are coming to the support handle of this particular utilities company. So what we are doing to the incoming tweets is we are performing topic modeling and sentiment analysis on them, and then finally showcasing that in real-time sentiment analysis. So altogether, all this data is visualized in the four views that we discussed earlier of network KPIs, real-time asset monitoring, real-time sentiment analysis, and real-time case management. So I'm just gonna show the capabilities that we have used, the TIBCO capability. So we use real-time event processing, case management, microservices, and visual analytics. And this is the BOM where you can see what are the exact products we have used in this particular demo. Now we will move on to the demo. In the first view of network KPIs, we are looking at historical trends in issue resolution. So we are basically looking at how the complaints are logged in year 2018 for all the months. Okay, so to the left top, we can see that number of issues that are logged, and then this is number of amount of time that we have taken to resolve this particular issue. So we basically there are three major types of damages or anomalies that are getting detected. So one is motor failure, the other is pipe burst, and there is water pressure issue. Okay, so if Spotfire allows us to interactively select and look at the data for areas of interest. So these are the various regions in the network. Okay, I'm looking at how this region is performing because this region holds the highest number of issues. So I can see that in this region more number of cases are basically logged in July to October. Okay, and then mostly around motor failure. Okay, so I can select any region to basically see what is happening in that region, how are issues getting raised, how are issues getting resolved, what's the time for resolution. So not only at the region level, Spotfire also allows to actually look at the network at a sensor site. Okay, so this is the sensor location that we have. So if I want to see what are the issues that have been raised and when are these issues raised for this particular sensor uh, at the sensor location, I can just click on it to see what's actually how many cases have been raised here, what's the overall time that we have taken to resolve these issues. Okay, so this is a simple business intelligence view that we have created. Okay, so this is a conventional business intelligence use case that we wanted to showcase in the initial view. So moving on to the next view, this is this view is basically to monitor the network in real time. Okay, let me start this real time simulation. So now that I have started the real-time simulation, you can see the sensor data. So to top left, you can see the entity. So these are the sensor locations. Okay, by actually address of the sensor location and then the region where the sensor is located. Okay, right now we could see all of them are in status okay. We could see, so these are, I mean, this is the network. Okay, so again, the locations where we are getting readings from. Okay, so we are looking for pressure anomalies, okay, in this particular plot. So you could just see that at location ESB 0 we just got a pressure anomaly and motor amps anomaly. Okay, and then the status of this particular sensor has changed to faulty, and then there is a pipe burst. Okay, at this particular location. That's what I mean, that's the anomaly that got detected, and issue that got issue got classified into a pipe burst. Okay, now this particular readings are motor amps readings and pressure readings that we could see here. So what we are looking at right now is the latest sensor reading right now. Okay, you could see that sensor readings are moving. Okay, so basically this is the lower limit for motor amps that we have defined, and then you could see for sensor 0 uh, it has come below the lower limit. Similarly, the pressure limit for sensor 0 is has again gone above the upper limit of pressure limit. That's the reason why both the pressure anomalies and motor amps anomaly got triggered. Okay, and then we can see the 0 location of the where the anomaly got detected. And then basically this particular view is giving us how overall network is performing, where are issues at this point of time. Okay, and then what's the latest sensor reading at each location, right? So to just I mean, we talked about how we are, we have added in a layer of social media data to look at what are the issues, what is the sentiment of the people across the network. Okay, so what we have done is we have actually picked up data from the support handle of this particular water network company, and then you can see that from the data extracted we were able to actually uh, populate the topic identifying words. So for let's say we have done we are modeling for 4 topics here. Okay, and then topic 0 mainly revolves around sewage water, drain overflowing, bridge getting spilled, etc. And then topic 1 is again looking at uh, how roads are bad, how customer care is answering um, some of these issues. Okay, and then topic 2 is again we are looking at some of the corporate messages that have gone from this particular handle. And then 4 is again how customers are responding to the customer service. So they're talking about they'll check back the status of the repairs in morning, etc. Okay, so basically this gives us a view of what this topic is entailing. uh, and then this is that distribution of the topic. By topic 0 we could see there are around 137 tweets, and then the average sentiment for these tweets is around 2.4%. So the tweet sentiment will range from minus 100 to 100%. So we could see that topic 1 and topic 2. Okay, topic 1 which is around the customer service, and topic 2 which is around corporate communication has the maximum sentiment going around. Okay, to understand the sentiment around a particular location, we can simply select on a sensor location. So I just selected location ESP1. Okay, I can see that there is this particular tweet has a maximum negative sentiment. So The tweet that is coming in is something like disgusting as always. So this particular customer didn't like the service, and then okay, so this says day 4 of a block sewer and cannot use our bathroom. Okay, under resource. So you could see how people, I mean, how these tweets are coming in, how negative they are, based on which we are able to give it a negative sentiment. Okay, so that way we'll be able to actually layer in this contextual information of tweets that are coming in from social media, and then based on I mean, mapping them to the locations of the from where the sensor data is emanating. We will be able to actually understand more about the network, and then how customers are responding to what is happening inside the network. Now let us go back and check the status of the network again. So we could see that when we moved on, we could only see one fault, but in this current simulation now we can see there are five issues. Okay, three of them are pipe bursts, couple of them are motor failures, right? So now let us see how these. I mean, let's track these issues and see who is actually responsible in fixing this. Okay, so we could see that these are the cases that are currently in. Okay, so we have five cases. Okay, and then we have resources who got allocated these to these cases, and then we have the status of these cases. Okay, I can select a particular case to look at how I mean, to look at various readings. So I can see this is a current sensor reading. Okay, I can see what all anomalies got triggered historically in the anomaly details. Okay, and I can see what is the pressure, I mean, motor amps and pressure data historically. Okay, so let us look at a different one. So you could see how, I mean, pressure was under limits, and whereas motor amps was over the lower limit, but suddenly the incident happened, and pressure increased and motor amps decreased. So what we'll do now is we will look at, I mean, so what would have happened is there is an automatic, I mean, this case got automatically allocated, and the resource would have received an email. So we could see that emails have been received by Mayor Lampel, who is one of the resource here. Okay, so he received an email with the location details, with the, I mean, what is the entity, okay, what's the pressure reading, last pressure reading that was observed, and then what's the damage type that got classified, and when the event got logged. Okay, once resource starts to work on this particular case, what he can do is he can just open the case that's assigned to him. Right, this is the case that was assigned to Mayor Lampel. Okay, so we could see all the details, right? So what he can do is, once he tries to fix it, he fixes this issue. So he can change the status to restored. Okay, otherwise, if there is, I mean, if there is additional assistance needed, he can request for that as well. But now, for now, in this case, I'm saying restored. Okay, and then we can say fix the leak, right? And he clicks on submit. So once he clicks on submit, the case gets completed, and then same should reflect in our live dashboard. So now, so this was a case active complaint earlier, but now you could see that it is now a recent complaint which is in status complete. Okay, so this way we could look at the issues, and then this is like responsive dashboard from where we can monitor all the complaints, what's the status, how are they getting resolved, with the kind of anomalies that are getting detected. That's the demo, folks. I hope this recording is useful. Thank you.